You ready to go? We're rolling. All right. Welcome back to Stories Worth Sharing. My name is Chris Recksteiner, and today we're going to be speaking with Paul Armenakis. And Paul is a man of many roles and responsibilities within SCTG, but today we're going to be speaking very specifically about the Folding at Home project. Paul was instrumental in our organizations and our customers and our community's involvement in this process. And in this conversation, we're going to go into some detail about what Folding at Home is, what is required or needed in order for you to participate. And hopefully what we can deliver and what you can take away from this is some awareness of how you can contribute to what is a really tremendous effort. And with that, here's Paul. Paul, thank you for taking the time to join us today. Really appreciate it. I know everything is busy right now, more busy than usual, which is the opposite of what everyone expected.
Yeah.
And everyone expected this to be quiet. It's not quiet. But today I want to dive into the Folding at Home project. You've been instrumental in helping our organization and lots of our customers get involved in this process. And what I want to do is just sort of open that can of worms and dive in and share a little bit about what Folding at Home is, how you came to be aware of it, what we've done, what other organizations are doing, and just share that information because I think it's a really incredible process and an incredible project that has been put together. And if there's a way we can, get more people aware of it and increase the support for it, we definitely want to do it.
For sure. Yeah.
Sounds awesome. Great. So tell me a little bit for everybody who doesn't know, and I had to go look all of this up when we first started doing it, and it took us a while to get this conversation organized. Again, nothing's quiet and calm right now, but I had a chance to do a little bit of research into it. But share a little bit more about what the Folding at Home project is and sort of how you came to be aware of it and participate.
Sure. So Folding at Home itself is a distributed computing platform that uses people's home computers or computers in data centers or companies. Anybody can contribute to it. And essentially what it is it focuses on simulations of protein folding. So protein folding is essentially what our body does to take proteins that are essentially unfolded and turn them into things that it needs to live. And the big catch is that there are a bunch of ways that proteins can fold, and we don't really know much about how that process works. It's a process that takes a little bit of time. It's not an instantaneous thing, and modeling that is a huge computational undertaking. And before the Folding at Home project kind of came out in 2000. The modeling periods, the amount of computational power we had was incredibly limited, and we couldn't really model protein folding for any sort of decent period of time. And so what this looked to do was to say, all right, there are these giant supercomputers out in the world, and they do various things, and oftentimes they're competing for different projects for researchers on everything. And there's at the same time there is an enormous amount of processing power in everyone's homes. Throughout the 90s, the personal computer became a big thing, and most of the time they sit idle. They don't do much. Even when you're using them, if you're browsing the web, your computer is not doing too much.
The fan is not running.
Yeah, exactly. It's not a thing where it's you're using 100% of your processing power. So what it looked to do is take those computers, all those millions of computers that are in that is in everyone's home, and use them like a virtual giant supercomputer. And it uses a piece of software that gets installed on your computer, and it essentially crunches a very small portion of a much bigger project. And you're kind of almost like a hive mind mentality, where everything is doing its little part for this much bigger piece of the puzzle.
Okay. Wait, that sounds a lot like the SETI project. Is it similar structurally? Obviously, it's with a completely different goal, but technologically similar concepts.
Very, very similar. Yeah, very, very similar. Using processing power and taking any sort of simulations that need to be run, or analyzing data, and using processing power to do that.
When did you come across the Folding at Home project?
Yeah, it came out in 2000. October 1st, 2000 was its kind of initial release date. And
so it's brand new.
Yeah, absolutely. Yeah. Yeah, for sure.
Only 20 years ago.
Yeah. So, but back then, obviously computing power was much less than it is today, but the idea was the same. And I was, and still am, a member of the online computer hardware website, Anantech. And Anantech has been around since the 90s and in various forms. And they have a very passionate kind of hardware enthusiast group, and on their forums, the Anantech forums are very popular. They've been around forever. And one group of their forums is the distributed computing group. So that's how I initially found out about it. Their team in Anantech is still alive and kicking. They're currently ranked. Let me look. They're up there. Team in Anantech is, I'm not going to find it.
Of course,
they're 17th worldwide is Team in Antec. And
out of how many teams are currently?
Thousands and thousands.
The last time I had looked, it was like the little breadcrumbs of what you can click for the next page.
Yeah,
it scrolls the 250 participants is like goes off the browser. It's like, okay.
Right. Yeah. There's one of the websites that tracks all of your rankings and things. It goes to 12,000 in terms of teams. And so a lot of those teams are now defunct. It tracks historically, so they're not all doing things, but yeah. So Anantech has been around for a really long time, and they're very passionate about that. So yeah, initially was started doing some folding on my Pentium 3 or whatever it was back in 2002, and kind of had small contributions. I certainly wasn't a major player in it, but the idea stuck, and it was very cool, and something I had kind of forgotten about for a couple years, and just kind of I was in college, and then working on my career and stuff, kind of focused on other things, and then much more recently, with all of the things that are happening with the current pandemic going on, Team Anantech, periodically they do these competitions with typically with Tom's Hardware, which is another big hardware enthusiast forum. And so Team Anantech and Tom's Hardware, they have their members, and they do these little, how many points can you get in a certain amount of time? We'll start, January 1st and go until St. Patrick's Day or something. And so they'll do those things in kind of friendly competition, and it's all for promoting research. And so they had another one for the COVID research. And so started thinking about it. I was like, there's a lot more, I have access to a lot more computing power now than I used to, both personally and through SCTG. So that's
just a bit.
All started, yeah, just a bit better than
a few data centers around the world full of
2002, a little more than my Pentium 3, yeah. So that's kind of how the whole project started. I started doing some things for Team Anantech, recently, and then I said, what? I bet I could get a lot more people into this, and they're, it'd be a lot more important to them knowing that they're contributing things, we're all part of our little group as opposed to this massive group with thousands of users. So,
well, and it's super timely as well, because everybody's been impacted by that. So when, as you're watching this and that ask comes out, nobody's questioning, what are you talking about? What are we trying? It is top of mind immediacy for everybody. So I would imagine makes it really easy to sort of marshal the forces, if you will.
Yeah. And the other thing is that it, especially in the early, back in March and February, March and April, I think there were a lot of people saying, what can I do? I'm not a biomedical researcher. I'm not, I'm not a virologist. I can never say that word, but I don't work in the medical field. I don't know how to contribute to this. I'm just, a worker, doing some other field that seems irrelevant, and how can I contribute? And so this is a great way to, have everyone contribute a bit, and collectively, we can help enable those people who are doing the research, who are at the forefront of the medical community, and give them the tools, because they're not in the technology field. They don't have access to the kinds of compute resources that either us as a technology company, or even the IBMs of the world, or just the general population at large. If you think that large, they don't have access to resources like that normally. So it's been really great to see so many companies, but also individuals that just contribute. I mean, every little bit helps. I mean, as I look right now, the number 2 team of all time is the default anonymous team, who aren't contributing anything to a team. They're just, hey, I just want to crunch numbers and help. And so I think that contributes a lot to, or goes to show, I think, a lot of where people are at and what their mindset is and things. They're not doing it for recognition. They just want to help in whatever way possible.
How difficult is it to get set up and for people to engage in the process? Because when you think about the volumes, and if you've been to the sites, and we'll put all of this into the notes, but when you think about what the scale of this really is, it's massive. It's staggering. It really, when you look at it and it's like, oh, well, it's a lot of people doing a lot of things. And all of a sudden, as you start to dig through it and realize what that means, it's really, it kind of takes your breath away to say, okay, hold on a second. The scale of this is way beyond what I was imagining is happening. So I'm assuming it's very straightforward for people to participate.
Yeah, it's really easy. It's nice because even though the Folding at Home project is incredibly distributed, and it's essentially anonymous, it's just various people doing various things. That the center of it is a very kind of strict. How can we get this out to everyone in the easiest way possible? And there are central servers that hand out work units. It's not like you need to go off and find things to do. Essentially, all you need to do is install the client. So pretty much, if you go to the Folding at Home website, there is a download link for Mac and Windows and Linux, and essentially you download the piece of software, and it automatically detects what kind of hardware you have. If you have a graphics card installed, it'll use that.
Cool. So it'll do a GPU, CPU.
Absolutely.
Identification, and then apply the resources accordingly.
Right. Yeah. Exactly.
Cool.
It runs on a bunch of things, actually. On a quick tangent, I mean, they've got it to run on one of the major jumps they had back in the 2000s was they got it to run on PlayStation 3s. And so there was a huge increase in processing power because all these PlayStation 3s were, when they're idle time, when people aren't gaming, they were using those. And the graphics cards are typically a lot more powerful than processors. So
when I was researching it, it's funny you mentioned that, because the one thing that stuck with me was the fact that one of the original processes was Sony Xperia smartphones.
Yeah.
And I saw that, and I have a lot of background in the consumer and enterprise mobile space. And when I saw the Sony Xperia, I started laughing and thought, wow, that brings back so many memories of people, racks of these things being used to test applications and test services. It's like, oh, okay. And just using that for a different purpose.
Yeah, absolutely. Absolutely. You basically install the piece of software off the website, and there is a small control program where you can kind of control what it does. So you can pick. There are several diseases that they typically focus on, such as Huntington's and Alzheimer's and COVID now. And so you can pick one, or you can just say any, and then you basically choose when you want it to run. So you can say, have it run all the time, no matter what, even if I'm working, and my computer might run a little slower for things I'm doing, but that's okay. Or you can say only run when it's idle. So if you've been away from your computer for a couple minutes, it'll just automatically kick on and start doing things. And that's essentially that, and an internet connection is really all you need. It'll download little parts of experiments from their central servers, crunch the data, and typically that takes anywhere from a couple hours to a day. And then once it's done, it'll send that data back to those central servers to aggregate all of the little parts into one actual experiment. So yeah, that's really all you need to do. As long as you can connect to the internet, it will do everything else for you. And you can select it. I mean, you can get very advanced with it. There's, central controllers. If you have a bunch of computers, you can control them all centrally. There's, things you can do with advanced settings and things like that. But essentially, if you want to, keep it simple, then yeah, download the piece of software and tell it when you want it to run, and it'll just do its thing. It's very, very
so you can contribute or you can compete. And you just kind of tune into that little competitive nature of people and say, well, by the way, you can aggregate all of your capabilities.
Exactly.
And all of your available processing power and really make a big contribution. And oh, by the way, here's where you're going to end up on the leaderboard, or you're going to see that reflected in a very different way than, like you said, your Pentium 3 that's in the corner running.
Yeah. They have some things to try and encourage kind of that competitive nature. Some people say they gamify it, and so essentially, yes, if you want to get on the scoreboard, so to speak, there's a pass key you generate and download a pass key so that you can prove that you are you. You get a user account, and then you can contribute to an existing team or create your own team. That's all for free. You can create a team online. It takes 2 seconds. And then anything that you crunch or anyone that completes a unit on behalf of your team number, it automatically gets contributed to that team.
Okay.
Yeah. So you basically you create a team if you want. You create your user account if you want. If you don't, like I said, you just go into that default user account and then start crunching on behalf of whatever you're representing.
So how many people in different organizations ended up contributing into the SCTG team? I know there was a lot of interest, and I should have gone and done all this homework before we had a chance to have this conversation, and unfortunately I didn't get any of it done. So I'm hoping you know the answer to that, because I know that it was something that you were very instrumental in from the get-go and communicating out to the team. And it began with a lot of our team members contributing and aligning to support that. And then that grew to some friends of the company and then to customers and on down the line. And it became a pretty significant group of people and a pretty significant amount of resources that were contributing.
Yeah, it's interesting because I don't know how many customers have done things, because you can contribute without us knowing who you are. Essentially, you can contribute. If you create a user account that isn't your name or some other identifying thing that everybody knows, then essentially you're anonymous. So we have it looks like as of this we have about 41 different users. Some of those are SCTG team members, and some of which are, like you said, customers or friends of the company. So it's been a pretty good mix. There are definitely people on this list I don't know, and so that's actually been kind of
friends of the firm.
Yeah, that's been kind of an interesting thing. We have an internal Slack channel, and we've been saying, all right, who is this person? I don't know. They're contributing things, and we don't know who they are, but that's okay. You're contributing to a good cause, so great. So it's been friendly that way. But essentially, how it started. I essentially went to our leadership team and said, hey, I'd like to start this team. I think this is something that we can contribute. We're a technology company, and not only that, but many of our team members are technology enthusiasts, and they have good gaming computers, and they game in their spare time, and they like tinkering with hardware and all of those sorts of things. So we're a pretty good group for it. And so chatted it over with our leadership team, and they essentially said, yeah, here's some resources, and see, how much we can do with it, and see how much we can kind of crowdsource this and get people involved. And so it's been interesting. It's we've even had some people within the company who aren't really in technology roles, who have become much more into the technology and gotten into what this world of kind of the higher performance personal computing is like, and purchased their own machines and really gotten into it, which is pretty cool. I wasn't expecting to see that. So everyone's been adding things. There's people with their home labs that they've been contributing, and we have a couple of users who have, they have several kids who game, and so they have gaming machines, so they've been contributing, and it's cool to see everyone just kind of helping out in their own little ways. And then definitely, yeah, when it got out to some clients of ours and they wanted to contribute, and some friends of ours, we've had some just a whole group of people that have really contributed. It's been great.
So once you set this up and you have it going, do people tend to leave it running in perpetuity and change the projects they're working on? How does that work? Because I could see very similar to any type of application that isn't having an impact on what you're doing, right? It's very much out of sight, out of mind. We always term that the health club model. You subscribe to the health club, but do you really go? No, you just pay it every month. And some months you do and some months you don't. But I would think there'd be a lot of similarity here, where once you have that installed and running, it's kind of set it and forget it, right? It's like the Ronco of apps, and you just go and it just continues to contribute. Do people tend to go in and change how they're allocating those resources, or do they just get set and then they just continue?
I think it depends on the person. I think there are some people who love to tinker, and they love doing the constant, hey, can I, it's kind of like the overclocking world in computers, right? Can I get that extra 3%, out of this? And it's more about the principle than the actual gains. Is that worth it, spending 3 hours on that? Maybe not, but it's fun. And so that's cool. And there's a lot of other people, kind of myself included, is, my client just sits and runs. And so, I have mine going when it's idle. And so when I'm signed out for the day, I leave my computer on, and I can, it just kind of goes. And it's very simple and straightforward. And the nice part about that, and just kind of, set it and forget it, is that you don't need to babysit it. It's not a thing that you need to remember, oh, I gotta, it's like an alarm clock. You don't need to remember to set it every night, and oh, this is too much work and not worth it, and that sort of thing. It's very, very straightforward in just kind of letting it run for forever. And the nice part is that as computers get faster, when it comes to the researchers, they just get a bigger computer, essentially, as a whole, right? The next time an NVIDIA or an AMD comes out with a new graphics card and people start using those new cards, then the people who have those cards just contribute more than they did. And that's really nice. You've seen, if you look at the history of the project, the amount of processing power that they've had has been astounding. They've had just leaps and bounds. They were of milestones, and being the first of being at these milestones at 1 petaflop, at 2 petaflops, 3 petaflops. These are these milestones. Recently they've actually hit 1 exaflop, so 1,024 petaflops, and they've been the first. And that's been a recent thing. They've had a huge surge of compute power from this pandemic that's been going on, and everybody's been wanting to contribute, which is really, really great. And so they've expanded. I'm not sure the percentage. I'm not going to make up numbers, but a huge amount of extra compute. So much so that they during the early days of this pandemic in March, they actually ran out of work units to assign. they didn't have any work for anyone, and so we were all kind of waiting, like, all right, trying to do tricks to get more work units, to get more credit, and that's that attributes to the tinkering, right?
Absolutely.
If I stop and restart the services, it's going to check again, and if I just let it sit, it won't check for another hour. So I'm going to have to keep checking and waiting for something, and I mean, it's a great problem to have. It's a great problem to have for these universities and these research organizations to be, have too much compute. I mean, that's a thing that's never happened. They always have things to do, and so they had to kind of start feeding the system more as the resources got more and more. So it's really great, and I hope that as this pandemic hopefully starts to subside, and we start getting good research and start getting, potentially, treatments and cures and vaccines and all those things that people want, that the other diseases that are related to protein folding, the Alzheimer's and the Huntington's and the Crohn's and the cancers, those sorts of things, that people stay with it. And that's what I'm hoping. I'm really curious to see, all right, when this is all over, whenever that is, and who knows, but that the amount of compute power of the Folding at Home project stays, at a high level, as opposed to going back to what it was before. So ultimately, I mean, there's very few silver linings in this current situation, but it is one of those things that's nice to see people contributing more to these sorts of things, and that there are obviously, so many diseases and things that need research, that need to be solved.
Mm-hmm. Absolutely. I could not agree more. I think one thing that I've really been watching, pardon me, as we've gone through this whole process, is also seeing that jump that you mentioned and wondering, and my wife is a cancer survivor, and wondering how this applies backwards.
Yeah.
Once again, assuming we get to a point where this does get a resolution, or enough of a resolution that people can push it forward, does it apply elsewhere? It's like, it's been such a great marshaling of resources to see it stay and to continue to be applied. It's like, that would be great. That, like, what can we do? And it's something I've been thinking a lot about, is how can we help really drive that thought process forward? It's like, okay, this is great, and look at what happened. Mm-hmm. And if it does contribute to it, the immediacy and the urgency that came with it might actually be the catalyst where somebody can say, oh, it does make a difference. I saw that I did X and Y was a result.
Yep.
That'd be wonderful.
Yeah.
Absolutely wonderful to see it.
Absolutely. That's one of the nice things about the project, is that it's broad enough in scope. It's not, the COVID-19 research project, or the Alzheimer's research project, or the Huntington's research project. It is the Folding at Home project, which is this fundamental thing that, that protein does. And so there's all these diseases, and I'm sure there's ones that we don't even know about, that, that could potentially come up in the future. We're seeing it right now. And so by understanding the fundamentals of how the human body works, that helps everything, right? If you can understand more about ourselves, similar to what you said with SETI, and that all right, SETI is really great for exploring the deep space, these things that we can't really see. They're far away, but there's also things that we can't see that are right here, right inside of us. And so there's that research that needs to be done, and understanding that needs to happen, that we're not there yet. And so there's and I think there's always going to be those things. And it's wonderful to be able to contribute to that.
Awesome. Totally agree. Well, Paul, thank you so much for taking some time today. I know your schedule is completely packed, as is everybody's. Thank you very much for spending a little bit of your morning with us, sharing some insight into all of this. And on behalf of everybody within SCTG and outside, thank you for organizing this. It's been awesome to see, and I really, really appreciate it. I know a lot of people do, and thank you, man.
Absolutely.
Cannot tell you how
together. It's been great to get the word out.
Excellent. We will do our best, and we'll come back and do this again and dive in on something a little bit different.
Sounds good.
All right, buddy. Thanks a million. I really
Thanks, Chris.
appreciate it. Take care of yourself.
Yeah, have a good one.